Okay, sorry about that. That was indeed my mic not working. Should be all fixed now. Thank you for pointing that out, because I would have done this whole lesson without knowing that it was not connected. Alright, so let's start that over. Now, today we're going to look at the idea of a mole, which is more than just the animal in the ground, right? This is a unit. It's a word that means a number. We know that an atom, if we look at any given atom, has a mass number, which is the number of protons and neutrons together. We also know that every atom has an atomic mass, right? Every element has an atomic mass. And that is the average of all isotopes for that element. So if we look at carbon, right, any given atom of carbon, we can count up the protons and neutrons and say that is the mass number, but we can also look at the periodic table and pull the atomic mass of carbon. Right, and the number on the periodic table is given to us in atomic mass units, AMU, which is a special unit that we only use when we're talking about protons, neutrons, and electrons, right? The smallest pieces that we look at. But that's not very helpful for us as human beings who can't really interact with the microscopic world. We want a unit that we can actually see and feel and use. And that's where the mole comes in. 1 mole is 6.02 times 10 to the 23rd. Now that is a crazy big number. Right? That means that there should be 21 zeros here. This number is 1 mole. Now you can have a mole of anything, the same way you can have a dozen of anything. Right? I can go to the store and pick up a dozen eggs, I can go and get a dozen donuts, I can go and pick up a dozen pencils, I can have a dozen friends. A dozen is just a word that means a number. A mole is also just a word that means a number. And that is 6.02 times 10 to the 23rd. And the really interesting thing, the important thing about this number in particular, is it's the number we need to take this number in AMU and convert it perfectly into grams. 12 AMU, that's teeny tiny. We will never ever be able to touch 12 AMU, but 12 grams, that's a pen, right? That's something I could pick up and look at and hold. That's something I can weigh on a balance. A mole of something, right? A mole of carbon, a mole of oxygen, a mole of nitrogen, is what really allows us to do chemistry in a lab. Right? Without the concept of a mole, we don't have the ability to do anything. We can't do a reaction in a lab if we don't have this concept down, if we don't weigh out our ingredients and put them together the right way. And so it's really important conceptually, but mathematically, right, we're just changing the unit on a number we already have. Let's take a look. So oxygen, if we look at oxygen, let's get a little smaller here. 1 atom of oxygen weighs 15.9994 AMU. 1 mole of oxygen atoms weighs 15.9994 grams. And we already have this number. We already know what that number will be. We have the average atomic mass. It's up here on the table for us already. And we already know that if we look at our key, it tells us here's your atomic mass. So not only does it tell us the mass of one atom, it also lets us know how many grams would be in a mole of that substance. Now, the periodic table only has atoms on it. The periodic table only has atoms on it. And so, when I want to find the mass of 1 mole of a compound, I have to add up the masses of those elements. Right? Atomic mass is not just AMU, Kyle. It can be either or. That's the whole point of having the mole here. Right? That number, that 15.9994 that we see in the box for oxygen, is the mass of one atom in AMU, or 1 mole of atoms in grams. Right? Nothing equals the mole. The mole's a number. Right? The same way you can't say a dozen weighs 15 pounds. Right? A dozen what? You can't just say a mole. Right? It's a mole of atoms. It's a mole of oxygen atoms. It's different for everything. Just like I say a dozen people, or a dozen pencils, or a dozen puppies, or a dozen donuts, or a dozen eggs. Right? All those things are different. A mole means a number. It's 6.02 times 10 to the 23rd. That's the only thing that equals a mole. The mass of 1 mole of oxygen is 15.9994 grams. The mass of 1 mole of carbon is 12.011 grams. So if we go here, we go back. Alright, the only thing that is 1 mole is this big giant number. The same way a dozen is 12. A mole is a word that means a number. I can tell you that a dozen donuts weighs 1.5 pounds. And you know how many donuts that is. But if I say a dozen of everything weighs 1.5 pounds, that doesn't make any sense. A mole of oxygen, specifically 1 mole of oxygen atoms, weighs 15.999 grams. A mole of carbon atoms weighs 12.011 grams. A mole of any atom you look at matches what is shown on the table here. A mole of nitrogen weighs 14 grams. A mole of boron weighs 11 grams. Right, these numbers in the upper left-hand corner of the table represent both the mass of 1 atom and also the mass of 1 mole of atoms for that element. But like we said, the periodic table only has elements. So what if we have compounds? What if I have something like CO2 or H2O? How do I know what 1 mole of H2O or CO2 weighs? I have to add up the masses of all the elements. Right? If I said I have 1 mole of water, 1 mole of H2O, I have to say that's 1 mole of O atoms, and also 2 moles of H atoms. Find those masses and add them together. Now for something like water or carbon dioxide, that's a little bit easier. There's only a couple of things in there. But when we get to more complicated things like calcium nitrate down here, we have to remember how these parentheses work. This too will get distributed into the parentheses. I'm counting how many calciums, how many nitrogens, how many oxygens. It's 1 calcium here, right? 2 nitrogens and 6 oxygens. Because I get 2 copies of NO3, 2 of the thing in parentheses. So, again, the first step is to break it down. Calcium nitrate has 1 mole of calcium, 2 moles of nitrogen, 6 moles of oxygen. What about these? Take a second and break these down. If you have 1 mole of this molecule, how many moles of each atom do you have? When you take each of these things apart, we should end up looking at this. Manganese sulfide. 1 mole of manganese sulfide has 2 moles of manganese atoms and 7 moles of sulfur atoms. 1 mole of carbon tetrachloride has 1 mole of carbon atoms and 4 moles of chlorine atoms. 1 mole of aluminum sulfate has 2 moles of aluminum atoms, 3 moles of sulfur atoms, and 12 moles of oxygen atoms. 1 mole of carbon dioxide has 1 mole of carbon atoms and 1 mole of oxygen atoms. And then we consult the periodic table. Then we look at the periodic table and say, okay, how much does each of these things weigh? How much is 1 mole of carbon? How much is 4 moles of chlorine? Sticking with our calcium nitrate example, we look at the periodic table, right? We take their masses from the periodic table and look to try to find our whole compound. When we break down calcium nitrate, it's 1 mole of calcium atoms, 2 moles of nitrogen atoms, and 6 moles of oxygen atoms. When we consult the periodic table, let's do this together to show you where these numbers come from. calcium first. Calcium is right here. 1 mole of calcium has a mass of 40 grams. We are going to round to the nearest whole number because it does make our life a little easier. So this 40.08 is going to become just a 40. 1 mole of calcium atoms has a mass of 40 grams. What about nitrogen? Go back over here. We find nitrogen. 1 mole of nitrogen weighs 14 grams. We have 2 moles of nitrogen, so we're going to double that. We're going to get 28 grams. 6 moles of oxygen atoms. 1 mole of oxygen atoms weighs 16 grams. We're going to multiply that by 6 to get a total of 96. And then we're going to add these 3 things together to get our total mass of 1 mole of calcium nitrate, which is 164 grams. Let's give it a shot with those same examples we looked at a second ago. Here, we already know that 1 mole of manganese sulfide is 2 moles of manganese and 7 moles of sulfur. Let's find the masses. Let's get the actual mass of 1 mole of each of these things. When we add up all of the pieces for these compounds, we should get these numbers. Correctly finding the masses off the periodic table, multiplying them and adding them together the right way will give you this set of numbers. Now, this one in particular is an important one. 1 mole of carbon atoms has a mass of 12 grams. 4 moles of chlorine atoms has a mass of 142 because it's 4 times 35.5. Chlorine is one of the only elements that does not round to a whole number. Chlorine, excuse me, let's get that all nice here. Chlorine rounds to 35.5. It's not going to round all the way down to 35. It's not going to round all the way up to 36. And so when you look for this, if you got 152, you didn't take into account this 0.5, which is fine, because I'm only telling you about it now. Let's look at this one, this third one. Here we have 2 moles of aluminum. We have 3 moles of sulfur, just like we said before. And we have 12 moles of oxygen. Alright, this 3 distributes inwards, and we identify those those elements just like we did a minute ago. So now we're going to look. We need 2 times whatever aluminum weighs, 3 times whatever sulfur weighs, and 12 times whatever oxygen weighs. So we go back to the periodic table. Aluminum, sulfur, and oxygen. Can I get them all on the page at the same time? That would be interesting. They're all right near each other. Yes, I can. Here we go. So, aluminum has a mass of 27 grams per mole. Sulfur, 32. Oxygen, 16. So I'm going to take those numbers, the 27, 32, and the 16, and bring them down. 27, 32, and 16. Some quick math is going to bring me to these numbers, and then it's going to take me just a minute to do 12 times 16. And then we add these together. To get our 342 grams per mole. Now, not everything is going to be a nice clean 1 mole all the time. Once you know what 1 mole of a substance weighs, you can always find what 1 mole of a substance weighs because you always have access to your periodic table. You can convert, right? If I tell you you have 86 grams of carbon dioxide, we can figure out how many moles that is. We can look and say, I know 1 mole of carbon dioxide weighs 44 grams, right? We just did that one. That was our last example. 44 grams. 12 from the carbon, 16 from the 2 oxygens to give us our 44. So if 1 mole of carbon dioxide weighs 44 grams, I know 86 grams is right around the 2 mole mark. And I can use dimensional analysis to help me solve this problem. And remember, for dimensional analysis, it's what you want divided by what you have. I want moles, so I'm going to put moles on top. I have grams, so I'm going to put grams on the bottom. I have my conversion factor right here. 1 mole of CO2 is 44 grams. And then I can solve this out to get my answer, which is going to be 1.955. You always have the tools to find what 1 mole of something weighs. As long as you are given the substance, you are always able to find out what that mass should be. Periodic table is always going to be available to you. That mass is never going to move from the upper left-hand corner. So you always are able to find what 1 mole weighs. So no matter what they give you in a problem, you should be able to solve it through. And with with that, I'm actually going to transition us over to our Zoom meeting for questions, comments, concerns, and attendance. And I will see you there.